I
Right, here we are. I am going to screen share. We are looking at the, what is it called? Freaky factoring?
Yes.
I am looking at, let's just do some little quick algebra review really quick. So we're factoring, obviously. The very first one, if I'm seeing it right, 15 is x to the 5th, y to the 3rd. It's tiny on my screen. Matt, is that right?
Yep.
Yeah.
Okay, so when you factor this, the main thing is greatest common factors. Kate, you promised you would talk today, so look at that and tell me if you see greatest common factors.
There's a 5x to the 4th, y to the 3rd is in all of them.
Biggest we can get out? 4th, y to the 3rd, right?
Yeah.
Okay. All right, when we do and pull that out, then we are dividing what's left. And right here, the number 15 divided by the 5 is going to be 3. X to the 5th. When you pull out x to the 4th, what's left?
Just X.
What's the, is there arithmetic that just happened there? How did the 5th power become a 1?
You took out the other 4 multiplications of it.
What did we do to the exponents? 5, 4. How did we get 1 here?
Subtraction.
Right. Yeah, subtraction. You're right, Colton. This is the arithmetic of that, right? So that's a 1, which we would not normally write. And then on the y, the 3 and the 3, how many y's?
0.
Okay, so next would be then, see, now I'm stuck. 4?
Yeah.
4? Okay. And y to the 1, right? To the 1? Yes.
Yeah.
Okay. That is a simple factoring one. And I only go over that because it's going to get weirder. If you look even on the back side of this, of your handout, you have all kinds of insanity going on right there. But that does not change the principle of how you do this. So when you, for example, on B there, tell me if I'm right with this. X to the 8th. Someone tell me the rest of this. It's cut off. 72x to the 7th. What's after that?
X minus 5.
Hey, what power?
7.
7?
Yeah.
Oh, I could have figured that out. Okay. Okay, so there are, when we talk about terms, there are factors and terms. And 63, x to the 8th, x minus 5 to the 6th. All factors, multiplications happening there. Then there's this nice plus right here, which makes the next part a new term. What is in here and in here as a GCF? Start with the 6372. Eddie, you with us?
Yes.
Good. What is the common factor there?
9.
Okay. X to the 8th and 7th.
7th.
The 7th. It is, notice, the smallest one. We don't take it, even though it's greatest common factor, we don't take out the biggest number. We take out the smaller exponent to keep the common. So same principle, x minus 5, which of these powers are we going to actually take out?
6.
Okay, then a bracket with a plus in the middle of it to mean this plus right here is going to put our leftover stuff. 53, we pulled out a factor of 9, so we got 7. How many x's did we keep inside?
1.
1 power of x. How many of these quantities?
None.
Oh, none.
There set. Okay, 72, we took out the 9. I don't know, really I don't. What is it?
8. 8.
8, okay. And then x to the 7th, all of them pulled out. How many of these factors are left?
1.
1. X minus 5 to the 1st. Okay. We would not be done with the algebra of this until this leftover factor, this is simplified, which means distributing that and then combining any like terms. So 8x and minus 40, I think, makes that factor simplify to 15x minus 40. All the other factors just need to come back down and be a part of our answer. Okay? Do you have any questions about that yet?
No.
Nope.
It's going to get crazier.
Yeehaw.
I know, it's really okay. Now the next example is really important. Let me see. Yeah. Okay. So for the next example, they want you to find the zeros. And even though that says f of x right there, let me just show you something. I'm going to make a new expression. This is not on your paper. It is 5x cubed times x plus 7 to the 4th power. Now, what if this was a function of x, f of x, and we needed to find the derivative of that? What rule is going to get the derivative?
You'd have to do the product rule.
Who said that?
Me.
Who said that for real? Was it you, Kate?
Yeah, it was. I don't know if he's kidding or if he actually said it.
No, I was kidding. I was kidding.
Trying to snag the
Oh,
bonus.
I was like, are you kidding me?
That's for Kate. He's trying to snag your bonus point. Okay. Yeah, product rule. So using 5x cubed and then this quantity to the 4th as our first and second, then the derivative would be, okay, Colton, you have to do this because of what you just did.
What I just did?
Try to steal Kate's bonus point.
That wasn't me. That was Eddie.
Eddie?
Yeah.
Oh, I can't see who's talking. I've got my screen share on, so I don't even know who's talking. That's
Okay.
hilarious. Eddie?
Wow.
Okay, Eddie. Eddie?
Wait, me?
That's what you get.
Under the
Oh,
desk.
okay. So first, which is 5x3. And then derivative of second. Wait, how do you do that again?
Wait, I thought that would be chain rule.
Well, yeah, but there's a chain rule inside the product rule.
Oh, okay.
Wait, so do you bring down the 4, right?
What do you think?
Yeah.
This 4 is going to come down here.
Yeah, and then you keep the parentheses,
Mm.
and then times 1.
What needs to happen in the exponent?
Oh, 3 x to the 3rd.
Then times 1.
Yeah,
Can we leave just as it is then?
yeah.
Okay. All right. Now, Colton. Got half the product rule done. Can you finish it?
Then you add, would it be x plus 7 to the 4th or just x plus 7?
The second is x plus 7 to the 4th. It's that whole thing.
Okay. So yeah, then add x plus 7 to the 4th. Or, yeah. And then multiply it by 15x to the 2nd.
Okay, now look at your handout and tell me how this here compares to example 2, part A.
What?
Whoa, it's the same thing.
Same?
Well,
Except for in example 2, part A, that said f of x, and now it says f prime of x. So if you guys want to tweak that on your notes there, I only had it this way because, like you noticed in class, we did this back in pre-calc, this assignment. But when we did it then, we didn't have any derivatives. We didn't know that this would be a function called f prime, but we did have practice finding the zeros. So why would I want to know the zeros of the derivative?
That's where like the tangent line is horizontal, right?
Mm-hmm. What happens in something moving on a line with their position velocity? If the position has a derivative equal to 0, what does that mean about the motion?
It's not moving.
Yes. Okay, so finding the zeros of a derivative is a pretty standard kind of question. So how do we do it in this kind of a problem? It's going to require that you guys can simplify this in a way that's going to make it useful. And so it's really similar to this up here, where we look at this group of factors that are being added to another group of factors. And we want to look for anything common in there. What's in here that you also notice in here. Okay, Haley, are you with us?
Yes.
Holly, unmute because I'm going to ask you too for help. Can you guys take a look at this? And anything you see as a common factor, let's write it out as a GCF.
5x to the second and x plus 7 to the third.
Sure.
Yeah.
Okay. All right, so let's start with that. If there's anything left, then you're going to want a bracket where you can put the stuff that's left and plan on that plus right there coming into the new quantity. Okay, now here is something that I think helps keep track of stuff. Although it is going to mess up this derivative line right here. So if we were taking the quiz where you guys would be highlighting that line as your main answer of calculus, you might want to recopy it so that you'll see what's going to happen. It's going to end up with a bunch of scratch work all over. All right, so looking at our factors that we took out a factor of 5. For this, I'm going to cross out the 5 because I pulled it out. And over here, I also have to consider the 5 that came out of there. Now, what's still there if a 5 comes out of 15?
3.
3.
Okay. Same story for the x squared. I took out x squared, so this x cubed is now just the x. And in this set, that x squared is gone. Far so good?
Mm-hmm.
yeah.
Okay, next factor we took out was the quantity to the third. So that means when I look here, all of that is gone. And in this set, not all of it's gone, but what's this power? Took out 3.
1.
So it kind of loses its power. All right, so then I can visually see what's left. I have an x times a 4. So that's this 4x right here. And what do I have left here?
X plus 7
Times 3.
times 3. Yeah.
All right, if we're going to find the zeros of this, meaning we want to set this equal to 0, we need to have factors so that we can separately consider those. But this factor is not very useful because it's not simplified. So let's do the simplifying and bring the 3 in and collect these like terms. 7x plus 7. Everything else down.
Plus 21.
Plus 21. Yes. Thank you. So you guys know what x equals here? Or 0?
-7.
I'll remind you about the quantity to the third, that means that this has a multiplicity of 3.
Oh.
If you remember graphing, that means that when it hits the x-axis at the 0, that it crosses like a cubic with that multiplicity 3 rather than a straight through. What about this one?
-3.
-3.
And then one here too.
0.
And that 0 has a double multiplicity. So when we hit, if we were graphing it, multiplicity 2, that says multiplicity 2. If we were graphing it when the graph hits 0, that's a bounce off point. Okay. So for the rest of this, academy, I don't really care about finding the zeros because our goal right now is for you guys to be able to get derivatives like this into simplified versions. So like this right here. So if on our quiz that's coming up, if you can identify that line as your calculus and see how messy it got.
Any white ones like that? No.
Someone needs to mute there.
There's none of them?
This messy stuff isn't going to work when you highlight it for your answer. So if you do this strategy of crossing out stuff, please recopy the line so you can cross out for each cross. And then this would be your final answer for the simplified version. I would want you to have it factored. Got any questions on that?
Nope.
Okay, so I did not give Collie a chance. Actually, I'm not sure who's talking to me. Who am I not realizing is here? I got Haley. I actually need to write this down for 10 minutes. Haley, Colton, do you like how I didn't capitalize your name?
That actually bothers me.
There's also Peter.
Peter, are you here?
Making me a favor on your way home.
Hi, Peter.
Yeah, it said Peter joined.
Hi.
Can you
Oh, he's here. Okay. Is there anybody
grab
else?
some of those boxes, the middle, the medium size?
Okay. All right, so this next one, this is another one that's a derivative. Do you guys want to take the derivative or just the algebra?
I could get.
Just the algebra.
Does anyone need to see the derivative with product rule that has chain rule in it with it? Anybody want to see it?
Not really.
No.
Because if you do. All right, we got 5, we got 3, we got. Yeah, that was from a derivative right there. That was a first derivative, second. Here's a second derivative. Okay, do you see where the two groups are?
Yes.
Yeah.
Plus, here's the groups. All right. Peter, I want you to start looking for commonness.
No.
Would you start, please, with just the constant? Like right here is an easy one to spot. 5 is a factor, a constant factor. Is there a 5 factor in here?
No.
All right, then don't worry about that.
Wait, I have a question. Do you multiply like would you like multiply the 3 and the 6x to get 18x?
To simplify that, you know
Yeah,
what?
like-
I think that's a good idea to do that. It just puts stuff in order. Like the 3 and the 6, you said 18. What about the
Yeah.
x and the x to the 5th even?
Yeah, that's what I was
Yeah.
thinking.
That is really going to be a good idea to kind of organize all the messy factors you have right there and multiply any of the just single term factors together. This to the 6. Is that right?
Yeah.
Yeah.
Mm-hmm.
Okay, and then that brings this and this and this all into this factor, and then we have that quantity. These look like they're in a nice order already. Yeah, I like that idea a lot. Let's do that, okay? So kind of clean it up a little bit, and then we'll pull out what we can that's common. Okay, so what, we decided no constants coming out. What about x? Charlie, can you get any x's out of that?
X to the 4th.
And the quantity, how about the quantity?
3x squared minus 1 squared.
Okay, Haley, I don't know if you've already talked to me. I don't even know. I'm just staring at my list. What's left?
18x squared plus 5 times 3x squared minus 1.
Did anybody cross out stuff?
Mm-mm.
No.
I totally would have if we hadn't reorganized it and done this line. I totally would have, but it is for me. I can see that. If somebody couldn't see it, I would just say this became it was a 6 and we subtracted, so it became a 2, and all of that went away, right? This went away, and 2 out of the 3 of those are gone too. All right, so do you guys know the last step?
Simplify the bracket.
Simplify the bracket. We're going to distribute that. Colton, you got the rest of that?
15x squared minus 5.
Any combining? I don't know how to add that. Anyone? Anyone?
I think it's 33.
We all really like that stuck.
Oh, yeah. Rip.
Okay. I got to pull up the second picture. Thank you for sending these, Charlie.
Yeah, no problem.
Is that the whole first page? Are we done with the first page?
Yep.
Yes.
Oh, wow. Okay. Okay, what do you guys think of part C? Do you look at the next slide then? Part C.
So parentheses.
Do we need to do it, or do we need to go to the ones that are fractions and negative and all that fun?
I don't know.
I think we can go to the fractions and negatives.
Let's do, if we have time, because we do only have like 40 minutes on these meetings, so let's go to the fractions. If we want, we can jump back to the others. Okay, so does your exercise 3 say 2x to the 5 halves power plus 4x to the 3 halves power?
Yeah.
Yeah.
All right. Okay, so remember what happens. Obviously, we just take out from the numbers a 2 and a 4. We'll pull out a 2. But there is common x factors here, and we can take out the greatest common factor. So again, when we had right here power of 6 and a power of 4, we took out the smaller of the 2.
Yeah.
The smaller exponent is what you can take out. So when you look at those two, what's smaller, 5 halves or 3 halves?
3 halves.
Pull out. Okay, so the 2 is out. x to the 5 halves, when a 3 halves power is factored out, you do what? What do you do with the 6 when you took out 4? What's the arithmetic there?
Subtract.
It's not different here. It's the same thing. So you got to do 5 halves and take away the power you pulled out, which is 3 halves. So what's the new power when you do it on the side?
2 over
One.
2.
Just x. And then what's here?
2.
4. 2.
You factor 2. No x's left. Okay, so that would be the answer for factoring that one. Nothing can combine and simplify there. Okay, questions?
Mm-mm.
Part B has some negative. Yeah, go ahead.
What happened to the 5 over 2 though?
It has been broken up into the 1 that was here, that's here, and the 3 halves. Now 1 is a common denominator, 2 over 2. So if we
Oh,
were
I
to
see.
multiply that back in, we would be adding those exponents.
Yeah, I see.
Does that make sense? And that's why when we pull it out, we subtract the exponents. So that just is the first power. Okay, are we good to go?
Yep.
Okay, so same questions. 9 and the 6, what's our common factor?
3.
3.
Power do we get a pull out of it? 8 or a 9?
8.
Here.
Negative 2.
Hmm.
One is you take out the lower power, the smaller power.
Oh,
Oh.
so
Less,
take out the
negative
negative
3.
So it's -3.
Negative 3 is less than negative 2. You take out the smaller one. We're good? Okay, Carly, what would you say for the first term of the remaining factor?
3 y to the negative first. Wait, what is it?
Yeah, what is it? What did we start with and then subtract what you took out? That's the rule. Write down what you started with, subtract what you pulled out.
To the first power?
Yeah. So just y to the first. Isn't that nice?
Mm-hmm.
It's a nice exponent. Right. Haley, I still don't know if you're with us.
Oh, yeah.
Okay. Haley, what's the second term?
2x.
Combining?
No.
So cool. But so one advantage of this now is if you needed to, you could find the zeros. You could, if you choose to, if it helps you for whatever you're trying to do, you can bring this one factor, which has that negative exponent, down into a denominator. There may be a reason to do that, maybe not. Maybe you just want to leave it as it is, but that would be okay. But once you have it in these factors, then you can manipulate it into new forms easier. Hey, I heard that.
Just like in class.
I know. Right, so part C and part D are both derivative. Chain rule, product rule derivatives. Oh my gosh. D looks super fun. Do you guys want to do it?
Yes.
Woohoo! C first. Oh man, I just wrote that wrong. You guys have this written down. You should be looking at. Think about what you would pull out. Colton, you're up.
Pull out x to the negative fourth and y to the negative 2. Or second. Whoops.
Okay. Let's do one more. One more thing you could pull out.
Do you want to pull out the negative?
Usually, yeah.
Oh.
It's kind of optional, but usually if that first term's negative, it's a lot of times helpful to pull it out too.
Alright.
Right. I think Peter's up.
Alright, the first term you can just put 3. And y. Y to the first power.
Everybody good with y to the first power?
One.
I think that is a yes. That looks good. Okay, Eddie, what's your last term?
Shouldn't it be add?
Yeah. Because you pulled out the negative.
X?
Supposed to be at volleyball.
Say that again,
It's
Eddie.
waiting for me.
It's just X?
X? Just X?
Yeah.
How does the group think?
Yeah, I think so.
Mm-hmm.
Yeah.
I'm so smart. Like,
What the heck?
How pretty is that?
Oh. Zoom Eddie is way different than class Eddie.
Eddie, you said something and I didn't hear it apparently. What did you say? What did you say? I'm just
What
going
did
to replay this. I can rewind, you know.
oh no, don't.
I can. Okay. Would you guys recognize if you saw your answer above that looked like that? Would you recognize it?
Yeah.
Mm-hmm.
Yeah.
Hope so. Okay. All right. Last one, unless we want to jump back to that one we skipped. I don't have the whole thing in the picture on mine. So is it 2x to the 5th? And then this, whatever that stuff is, to the negative 1/2? Is that a positive 1/2 on the second one?
Yes.
Yes.
Yeah.
And then is there more from there?
Nope.
No.
No.
That's it?
Yeah.
Okay. Okay. All right. Here's our chunks. What would be the GCF? Charlie.
2x to the 4th. Oh, more? Wait. So confused. Oh, and then x squared minus 10 to the half? Or
Power is
1/2
smaller.
power?
Which power is smaller?
Oh, the negative 1/2 power.
Okay. Smaller. Got that plus right?
Oh.
Can you do the first remaining term?
Was that a toilet flushing?
Oh my gosh.
There it was. Sorry.
Colton, are you with us?
Yeah, I'm here. I'm here.
Okay, good. When you're ready, can you do the first one when you're ready?
X. I think that's it.
Left so much room. Okay.
Yeah.
Okay, what's this one?
5 and then x squared minus 10 to the dang, I don't like these. Is it -1?
It's what you had minus what you took out. So I wrote it down to see if you could help.
Oh,
Isn't
But
it
also
one?
write it down for
One
me.
isn't
Yeah.
1/4.
oh wait.
No.
No, 1/2
No, it's
plus
not.
1/2
Never
is
mind.
1, Peter.
Never mind. It's 1. It's 1.
What is it? Kate, what is it?
1.
1.
So that's done. I'm noticing a theme. Seems to be ones left when we do that, right? Those exponents. Do you guys see that?
Oh, yeah.
I noticed that a lot. Okay. What's the cleanup? Who's on cleanup crew tonight? Collie. Clean her up. Clean it up.
You would distribute, so with the 5, and so you would get 5x squared minus 50.
I just said 50 because I was going to write 15. Okay. Is that it?
And then plus x.
So our final factored answer. What's this one going to be?
5x squared plus x minus 50.
Would you recognize this answer if it said this?
No.
No.
Okay, that's where I get really confused.
I love that honesty.
Perspective.
So is that where you're getting tricked up?
Yeah, I don't understand what you did. I kind of
Kind of what?
like I recognize it. I see the same numbers, but I don't know how it goes into
How
that.
it happened? Okay. Can
Yeah.
anybody help her out?
I have a question. So with the 5x squared plus x minus 50, would you like factor that or no?
Maybe. It depends on why you're taking the derivative. If you needed the zeros, then I would probably try to.
Okay.
Because if it's easier to find zeros if it's factored. I'm thinking that probably doesn't factor actually, but if it did, I would try, and if it didn't, then you might have to use like quadratic formula to find the zeros. But for our purposes right now, it's okay if you leave it like that.
Okay.
So back to Charlie's question. How did this happen? How did
Magic.
I can explain it if you want.
Ooh.
Are you waiting for us to explain it?
Yes.
You have the mic.
Okay.
Go.
Okay, so you know how if something's to the 1/2 power, it's the same thing as the square root?
Yes.
Yeah. So you change that. You see a 1/2 power, then you can like always think square root. And then since it's negative, anytime you see a negative exponent, you think denominator. So you smush that together and then you get a square root in the denominator.
Okay, I see it. Thank you.
I like the smoosh. This is the smoosh step right here. X to the negative 1/2 is a square root in the denominator. Good example. Okay, no poof then. Okay. All right, so tomorrow you guys will appreciate knowing how to do this. I know there's a bunch of problems that are going to be chain rule, product rule combos like these. and this'll help you get through this. And remember, you have a work day tomorrow, so you don't have to spend too much time tonight going through stuff. You can spend the class time tomorrow. And Haley, or somebody said today that we think we should listen to, it was Leslie, we should listen to music in class. Let's do that tomorrow. We have a work day.
Sure.
We'll
That's a
do,
good
Yay.
idea.
Yes.
we'll do some Eagles. You guys need
Oh
to
yeah.
Yes.
Haley finally speaks up. She's
Yes. That's good stuff.
Okay, you guys have any last questions?
Nope.
How much time do we have left?
No, I'm thinking we should have been done already. I wonder if it's cut us off. Apparently it didn't. Can't figure out. Okay, I'm gonna stop sharing my screen. Here we go. I have no idea how much time we have left.
now it's just Charlie's all big.
I think we have a delay, but I think it's whoever is talking.
It gave me a notification. It said that you can go as long as you want.
Really?
Not sure why.
Let's not do that.
You guys just want to
Yeah.
hang out? Because I got stuff to do.
Wait, I do have one more question. Have you
Okay.
been wearing that crown all day?
I know. This is what my hair looks like though, see? So I got in the car and I was like, oh my gosh, I can't do a video like this. So I did, but I did go to Krispy Kreme, not with my crown, but I bought a whole bunch of donuts. And pizza will be involved tomorrow too, so make sure you bring your money.
I have
I
$5.
want your money in the assembly, and that is how
Are you getting pied in the face?
No, I am not. Everything within my power will make that not happen.
Boys are like $20 behind girls.
Yeah, I was
No
gonna say.
Yeah.
Yeah,
Yeah.
we're like 1,113. The girls like 1,130 some.
Got him.
Yeah,
Wait,
we're gonna
wait,
smash the goal.
Oh wait, that doesn't make sense. Just like today's total?
Yeah.
I thought didn't the boys get like $200 from Mr. Brusberg's class, and then our class, we had the boys had a ton of money in my class today.
Might be a little hard.
Yeah.
Thought it would be higher than that. Well, no, tomorrow I will not be getting a pie in the face. If I do, it will not be pretty for you guys. If you think you've seen the word. I'm taking off the gloves tomorrow.
I still like that. Okay,
Glad I won't be here.
that's smart.
You won't? Oh yeah.
Yeah.
That's lame.
Everybody say goodbye. People are still like watching this, I'm sure, and they're going, what? Say goodbye.
Bye.
I'm ending it.
Bye.
Bye.
Have a
Bye.
good night.
Bye.